Okay, now we get into some of the real meat of actual electrical engineering. So here, volts. So 1 volt is the force needed to cause a current of 1 ampere to flow through a resistance of 1 ohm. V equals I times R. This is Ohm's law. That basically, if we have here a voltage source, E of 1 volt, and this little arrow means the current flow, which goes around in a loop from the positive terminal. This is your battery. This is direct current flowing around here, and it goes through 1 ohm of resistance, and your current is measured to be 1 amp. Then your volts, your 1 volt equals I times R. In this case, 1 amp times 1 ohm equals 1 volt. And that's your voltage side of Ohm's law. Ampere. Your definition: 1 amp is the amount of electron flow resulting when 1 volt is applied across 1 ohm of resistance. So here we know we have 1 volt, and here's our battery, and here's the arrow showing which way the current flows through our little 1 ohm resistor here. And so our current, which is an I, is current, equals V, which is volts, divided by our resistor. So we have, in this case, our our current is our 1 volt battery divided by our 1 ohm resistor. 1 over 1 equals 1. Let's say if it was a 3 volt battery divided by, no, let's make that a 9 volt battery divided by a 3 ohm resistor, then we had to have 9 over 3 is 3 amps of current, I. And there's this guy called Coulomb, C-O-U-L-O-U-M-B. 1 coulomb of charge, which is 6.24 times 10 to the 18th electrons, is delivered by 1 amp in 1 second. An amp is a rate of flow. It's how fast is your electricity going. Think of think of electricity like water in a river. How fast the current is means how fast is the water passing a specific set point. If you're, for example, have so many hundreds of liters of water going past between point A and B down your riverbank, that is equivalent to how many coulombs of charge are flowing in your wire, in your conductor or electrical component. The ohm. The ohm is the resistance. It is the resistance unit for the opposition to the flow of current. So 1 ohm will allow 1 amp of current to flow when 1 volt is applied across the resistor. And here's the other part of Ohm's law. Your R is your resistance, equals your volts divided by your current. And that means if we know we have 1 volt and across our battery terminals, and we know that we have 1 amp of current flowing through, then we know that the resistance, or the load on our circuit, you'll hear that term a lot, load, and that's what's drawing current, and that the resistance in this case is 1 volt over 1 amp, which reduces down to 1 ohm. So think of the resistance being like the ripples on the surface of the water, or if there's rocks or mud or anything causing turbulence in the water, with the electricity to water analogy, and it impedes the flow of current proportional to your voltage. Notice this little triangle up here, VIR. Some people draw it in a circle, but it's an easy way to remember Ohm's law's formula. Because V divided by I is equal to R. Think of V and I like a fraction. And that will equal the other corner of your triangle. Just like V over R will equal I, will equal your current. So think of V and R like a fraction, equaling the other side of your triangle. And V, by itself on top, is equal to I multiplied by R. So the one on top is equal to the product of multiplying the bottom two. The same thing works for distance and time and rate of speed, and E equals mc squared, and for mc squared, and all that. There's a certain algebraic relationship that you see a lot if you look into the sciences and physics and stuff. So that's the basics of Ohm's law minus power, which I may have in another card, but there's lots of resources online for power.